Last video, we talked about the important aspects to an experiment, and we talked about why they were important. Today, we're going to talk about what are other best practices to have in an experiment. So besides the 4 elements that every experiment should have, we do have to notice what is a best practice for experiments. So the absolute best experiments usually include randomization. Without that, we cannot make any inferences. Some form of comparison so that we can say what has changed, more, less, greater, less, hotter, colder, bigger, smaller. We have to have something to compare it against to see what the difference is. Double blind, which we're going to get into in a second, and have some form of a control group. Now, all of these guys make the best experiment. That doesn't mean that everything is always appropriate. It's not always appropriate to be double blind. Sometimes that's not necessary. And sometimes it's not necessary to have a control group if you're looking to see what different types of effects or what different levels have an effect on your experiment. So it's not always necessary. However, randomization and comparative, those are required. All right, so what is this idea of a control group? When we do an experiment, we do it for the purpose of comparing. Now, that could be a specific treatment compared to what the status quo was. And the status quo is basically what we hold to be true, or what we've believed in the past. That's our status quo. Now, it's also sometimes referred to as a baseline. It's some measurement where we can say if somebody is in a weight loss program, the baseline, the average diet, the average exercise level, what do we expect that to do? That's my control. That control treatment, now that is a treatment in our experiment, that's one of our levels that builds up into our factors, which provides us with a treatment, is applied to our control group. That's our baseline. That's what we're comparing things from. Now, this is why sometimes blinding is difficult, or why it's important even. When we know which treatment was assigned, it's really hard not to have that influence either how the experimental units behave or how we interpret those behaviors. So even if you think that you can do that you can remove yourself from that, knowing does affect your outcome. There's even a whole physics belief that just recognizing that something exists changes it. That's the same thing for experiments. So what we do, we take our controlled experiment, we have our baseline, and to that we apply blinding. Blinding helps us remove bias that might occur on behalf of the folks that are actually doing the experimenting. What is blinding? You're not actually poking someone's eyes out and rendering them blind. We are making certain things unknown. So when we talk about blinding, there are 2 different cases or classes of individuals who can affect the outcome. Okay? These aren't just the people who are participating in all aspects along the way of the experiment. These are the ones who actually affect the outcome. So that would be those who actually could influence the results. So those on the result end, so whether that's the subjects, the treatment administrators, the technicians, anybody that's included in the actual process, anybody that comes in contact with your experimental units, including the experimental units themselves, they directly influence the results. Think about a weight loss program. If you have a really energetic and really positive and motivated weight loss coach, they might see better results just because they know what they're trying to do. If somebody knows that what they're doing is the more effective route, they're going to be more positive and see that effect. If somebody believes what they have is a placebo or something where you don't know what it is, or you don't know that it's not supposed to have an effect, that can change as well. So those who influence the results, as well as those who evaluate the results. Now this is the part that a lot of people get confused upon. They get that first-hand side, those who influence the results. What they typically do is they will recognize the subjects as one group and the treatment administrators and the technicians as the second group. They see those receiving the treatment and those providing the treatment. But that's not it. Those are actually all grouped in the same kind of category, people who are influencing the results themselves. Now, the second group is those folks that are evaluating the results, judges, the treating physicians, anybody else. I love to give the example of, it was on an episode of Grey's Anatomy several years ago, and it was they were doing a treatment for Alzheimer's. The patient did not know what treatment they were receiving. The doctors were not supposed to know what treatment they were receiving. Now, just saying that neither the patients nor the doctors knew the treatments does not make that double blind. They both have an effect on the outcome. It was double blind because someone who's evaluating the results is not supposed to know what the treatment was. Someone who's determining how effective the treatment was on Alzheimer's, how does this person's memory now work? They're not going to say, well, okay, I know they had the treatment, so I think this is a little bit more effective than what they might think the same person who didn't receive the treatment would get. So be very, very, very careful about that. When you have all individuals in either one or the other of those cases, that's single blind. So that includes situations where you have the patient and doctor who is giving the treatment, not knowing. That is a single blind experiment. When everyone in both cases is blinded, that is double blind. So that's where the doctors and patients, the people who are participating in the actual outcome, don't know what they're doing, and the individuals that might, for example, at the end, test the results of the memory tests. They want to see what are the effects after so many treatments of whether it's the placebo or the actual treatment. That's double blind. The measurers and the persons involved in the output, that's double. Now let's get a little bit closer into a placebo. The placebo effect is based on the idea that doing any type of a treatment at all can sometimes impact the outcome. Now we have here that it could induce an improvement. Maybe sometimes that's going to be a negative reaction. Some people have specific beliefs. But a placebo can have very powerful outcomes in an experiment. So what we have to do is we have to separate out the effects of just believing somebody is receiving a positive treatment or a treatment in general. That knowledge, that idea, we're taking that out of the picture to just see what the actual results are. So the fact that I'm taking this pill, I'm not going to assume it's a magical pill that's going to treat all of my woes. I'm going to compare that against both aspects. Someone who's taking a sugar pill, which would be our placebo or our control, and somebody actually receiving the magic dose. Now we call that fake treatment the placebo. It is oftentimes used as a method of control, but the placebo is sometimes a sugar pill. It might just be telling somebody that they are applying magnets to their painful joints when all it is a little metal disc. It could be all sorts of different things. Placebos are one of the most effective way to blind subjects and those people who are administrating the treatment from knowing whether or not that subject is actually getting the treatment, to kind of take that aspect out of it. Now, the placebo effect, that happens when we call these guys sham treatments. They're lies. When these lies result in a change, that's a placebo effect. And that's the belief that just thinking that you're on a medication or that you're doing something that's going to help you or that you're doing something that's going to hurt you, that it actually does that. And sometimes people think of that as the power of positive thinking, or belief is the first step to achieving whatever you're doing. It's that placebo effect. Now what that does is that makes it so much more important to understand the power of blinding, the importance of control, the importance of comparative studies. It's really the heart of statistics. Now, placebo controls are amazing. You should use them in order to blind anytime you can. Now, if you're treating a rat, they might not know what you're doing. If you are measuring the amount of miles that a specific tire can have before it's worn through, the tire is not going to know. But the person who's actually monitoring them, taking those results, they do know, and that can still affect it. So we want to make sure that we include a placebo at all times. So we're going to take our 4 principles of experimental design, control what source of variations you can. Now those are the things that we talked about just now: control groups, blinding, and placebos, which kind of placebos combined A and B. Randomize what you can't control. The purpose of that is to spread out your variation. Replicate, which means repeat the process over and over and over again, because one time could be a fluke. If it happens 100 times, it's probably a lot less of a fluke. And then we block what we can't control. And blocking is another difficult thing to try to get in. Things that make the experiments difficult. The more factors you have in play, the more difficult it is to determine exactly which factor was the most powerful. And so what we're doing here is we're looking at all of these different factors in different combinations. Sometimes that might be levels within different factors. Maybe it's just that you have completely different factors themselves. Here we have an example of tomato plants. We get 12 tomato plants from a garden store. Now remember, our first thing that we do for an experiment is randomize what we can't control. They came from a garden store. I can't control the specific things that might influence this tomato plant. I can't control if they had person A watering them versus person B, and person A overwatered and person B did not. I don't know. So we randomly assign to our groups in order to account for that. Now within our groups, we've got our different factors identified, our different treatments. So treatment 1 has the control as instead of a fertilizer, it has some mystery powder with no water. Treatment 2 is a half a dose of the treatment with no water, and then treatment 3 is a full dose with no water. Treatment 4 says, okay, now we're going to water them, but we're going to do that same thing again. Control versus water, half dose with water, full dose with water. And in all of those, we compare against all treatments, juiciness and tastiness. And this helps us kind of figure out, well, is it the water that makes a bigger play, or is it the amount of fertilizer that makes a different play? So think about this word confounding. What does that word mean to you? When might you have heard it? I know I'm oftentimes confounded by the behavior of my students. I just don't get it. Confused, confuzzled, bewildered, lost. I just don't know. Well, we actually have confounding in experiments as well. Confounding occurs when the levels of one factor are associated with the levels of another factor. Those two factors are then confounded. Think about it this way. If I were to ask a student how happy they were with their experience in math, and my factors are going to be their grades and who their teacher was. Those are the things that I think are going to affect how happy they are. Well, when you think about it, who your teacher is might actually affect what your grade is in the class. B in Professor Wimpy's class might not mean the same thing as a B in Professor Scrooge's class. It might be that a B in Professor Wimpy's class actually is more like a C in Professor Scrooge. So that's confounded. The grades are confused by who the teacher is, and that alone might indicate or affect how happy a person is going to be with their grades. I've known many students who come from specific teachers who are ecstatic about their math abilities, and they think they know everything because they got an A. But an A with that teacher resulted in a 414 on the SOL, whereas A's in other teachers represent a 495 on the SOL. It's a very different thing, so they're going to have very different outcomes. Now, when we do have confounding factors, such as the idea of grades and teachers, we cannot separate out the effects of one factor from the effects of the other. I cannot separate how much of a role your teacher played in your happiness versus your grade played in your happiness, because the teacher affected the grade. There are other variables that are associated with factors that can also have an effect on the response variable. Things that maybe are not confounding variables, but other things. A confounding variable is that third variable that is intertwined in your experiment. Maybe it's the difficulty of the teacher. That is all wrapped up together. And what we're trying to do is trying to figure out how one factor affects the response. But if there's some sort of confusion, some sort of confounding going on in there, there's no way that we can tell how much each of those variables affect the outcome. So that's confounding. More guy, lurking variables. And I like this Family Circus cartoon. It says, I wish they didn't turn on that seatbelt sign so much. Every time they do, it gets bumpy. It's like, okay, kid, back that train up. You're way off here. There is a lurking variable present. Can you figure out what that might be? I don't know. Maybe it's turbulence. A lurking variable is when you have a variety of variables that may be influencing a given situation. And isolating the effect of one variable might be difficult because there are other things affecting that as well. There might be a lurking third variable that we need to think about. We discuss the potential effects of these on other variables. For example, in this case, a lurking variable might be the idea that there is turbulence. That turbulence is going to cause the seatbelt light to come on, and the turbulence causes the bouncing. So we have a lurking variable here. A lurking variable is when we have two variables that we're measuring and that we're trying to think about how it affects the, let me move that up a little bit. We have two variables, x and y, and we're trying to figure out how they affect the outcome. But there's some mysterious other thing going on out here, and that is going to affect both x and y. This is lurking. Now that we've talked about lurking, I want to go back and talk about confounding. Now, if we're talking about confounding variables, let's say we have two variables. We're trying to figure out how they impact the outcome. But one of those variables also affects the other variable. It doesn't just affect the outcome, it affects the other variable. That's where we say the teacher also affects the grade. Both of those, the teacher and the grade, affect how happy a student is with their math experience. So lurking variable would be the turbulence that turns on the seatbelt light that makes you feel bumpy, that freaks the child out. Okay, so there's some third variable affecting both, that's lurking. Confounding is when one variable affects the other variable, and both of those are being measured. We'll go into that in more depth in class. So it's just a few tips for the AP test. When we do stratification, it's extremely important that you justify why you stratified. It's not just I stratified because I wanted to have smaller groups. You stratified to identify common characteristics that we think are going to affect the outcome. When we're doing an experiment, the exact same thing is true about blocks. A block is basically a stratification in an experiment, but you have to justify and explain why you chose to block. Blocks, the whole purpose of blocking is to reduce variability. So if I know that there may be a difference between how the way a man might react to a certain medicine and how a woman might react, I would group them, I would block them by gender. That's to hopefully reduce the variability between the two groups. But do not be confused with double blinding. You got to understand, even if you have an assistant who sets up the meds and code them for each treatment, somebody out there knows who's receiving each treatment. It doesn't have to be the doctor, it doesn't have to be the patient. Someone out there is keeping track of who gets what, but those people are not involved in the actual implementation of the experiment nor the measuring of the experiment's outcomes. They're just a mystery person joining the two groups together, and the two groups never know what that is. Okay, the subjects, the administrators, the examiners don't know for something to be double blind. And also, Remember that surveys and observational studies do not impart any control. They don't change anything. Because they don't change anything, there is absolutely no way to say cause and effect. There is only the possibility of an association. They might be linked. We cannot say A causes B if we're just observing reactions or choices, or even asking questions. Only an experiment can actually get you to a cause and effect relationship. And again, surveys and experiments are very different because in an experiment, we have some form of control. We are applying a treatment. We are affecting a change onto the subjects, something that's measurable, something that we can compare our outcomes to. That amount of control, that amount of manipulation is required in order for you to be able to get to cause and effect. I hope this started providing you guys with a jumping off point for the rest of this chapter. Again, it's very important that we discuss this as much as possible in class. Please, 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 please think over the key ideas, maybe understand what it means to be double-blinded. I don't know, could be important to help you get through the rest of class. Thank you.